Okay, hello again. This is the chapter on electrolysis, and we're going to see what electrolysis means. The first thing is the process that is happening in here is that the electrolysis is the breakdown of an ionic compound using electricity. The ionic compound could be either molten or in solution. We pass electricity through it. This causes a breakdown of this compound to form different products. So this is what we call electrolysis. So it is the breakdown of an ionic compound, molten or in solution, by the passage of electricity. The setup that we're going to use is this. We should have, first of all, a container that has a liquid that conducts electricity. This is called electrolyte. So the electrolyte is a molten or aqueous solution that conducts electricity. Of course, in order to conduct electricity, it has to be an ionic compound. So basically, we have molten or solution of ionic compound. And remember that the word molten means the ionic compound is heated until it melts. So if we heat the solid until it melts, or if we dissolve it in solution, it will conduct electricity, because then the ions in the ionic compound will be free to move. So we need the ions to be free to move in order to conduct electricity. So that's the electrolyte. Now, in this liquid, we're going to put two rods, and these rods are called electrodes. So the electrode is a rod that can conduct electricity. So it has to be made of something that conducts electricity. Now, what are the substances that we know that conduct electricity? Either metals conduct electricity or graphite. Now, in most cases, we're going to be using graphite because graphite is cheaper. It is a form of carbon. So the element is carbon, but the substance is graphite. If we need to use a metal, then we usually use platinum, but then platinum is much more expensive, so the graphite is preferred. And then we're going to connect each of these electrodes or each of these rods to the ends of a battery. So one of the electrodes will be connected to the positive end of the battery using wires, and the other electrode will be connected to the negative end of the battery. Now, the wires have free moving electrons. Electrons are negatively charged, so the electrons are attracted to the positive end of the battery, so they are being pulled from the electrode that is attached to the positive end of the battery, so that electrode becomes positively charged. Now, on the other end of the battery, the electrons will be repelled away from the negative end of the battery, go through the wire until it reaches the electrode, so they accumulate on the electrode, so that electrode will have a negative charge. So the electrode connected to the positive end of the battery is positive. The electrode connected to the negative end of the battery is negative. And the movement of electricity in that part of the setup is a movement of electrons through the wire, attracted to the positive end of the battery, repelled away from the negative end of the battery. Now, inside the solution, there are positive and negative ions. Now, if the electrode is positively charged, it attracts the negative electron. The negative electron is called anion, so that electrode is called anode. The positive ions will be attracted to the negative electrode. Positive ions are called cations, so the negative electrode is called the cathode, the one that attracts the cations. Okay, of course, the presence of a light bulb indicates that electricity is passing through if the bulb lights up, or if there is no electricity, then the bulb does not light up. Okay, so this is the basic setup that we're going to have. We're going to have certain electrolytes, a certain liquid, and we're going to see what happens at the anode and what happens at the cathode. You should realize that metals or hydrogen form positive ions. So a metal ion will be positively charged, or hydrogen ion is positively charged, and as such it will be attracted to the cathode or to the negative electrode. When it goes to the cathode, it takes up electrons. So the metal or hydrogen ions go to the cathode to take up electrons, to gain electrons. Now, Non-metals form negative ions, and the negative ions are attracted to the positive electrode, and they give up electrons at the positive electrode. So the non-metals lose electrons at the anode or the positive electrode. So as a result of all of that, chemical reactions will occur. So let us see what happens when we do electrolysis of, for example, molten sodium chloride. Again, we're going to say, remember, molten means the solid is heated until it melts. That means if I have molten sodium chloride, the only ions that I have in the liquid are the sodium ions and the chloride ions. Now, sodium ion is positively charged. Remember, if you're not sure which is positive or negative, anyway, the first one is positive and the second one is negative. So if I say sodium chloride, sodium is positive, the chloride is negative, and you should realize that that is what it is. Okay, sodium ions are positive. They're attracted to the negative electrode, and we said when they go to the negative electrode, they will gain electrons. The chloride ions are negatively charged, so they are attracted to the anode. They go to the positive, and when they go up to the positive, we said they will give electrons. Remember that chloride ions, when they give electrons, then they become chlorine. But chlorine is diatomic, so I have to write it as Cl2. We need to balance the atoms and balance the charges. So I have 2 chlorines after the arrow. I must have 2 chlorines before the arrow. Now that means that before the arrow I now have 2 negatives, so after the arrow I need 2 electrons. Now there are 2 types of questions that will be asked. One question would be name the product at the anode. The other question would be what is observed at the anode. Of course, here name the product. The product is chlorine gas at the anode. What is the color of chlorine gas? You should realize that chlorine gas is a green gas. So what I observe would be bubbles of green gas. That is what is observed at the anode. Now at the cathode, we said the sodium ions go to the cathode to pick up electrons. Any positive ions will go to the cathode and pick up electrons. When they gain electrons, they become the neutral atom. Sodium is not diatomic, so it just forms Na. It's now balanced because I have 1 sodium before the arrow, 1 sodium after the arrow. And before the arrow I have 1 positive and negative. That means overall there's 0. After the arrow there is no charge also, so that charge is 0. Now if we say what is formed at the cathode, or name the substance formed at the cathode, it's sodium metal. What is observed if we see sodium metal? Remember, if a metal collects at the electrode, then what is observed is silvery metal or silvery gray metal. Okay, let's try another one. So basically, in most of the questions, what happens is you will be required to determine what happens when a certain electrolyte is electrolyzed. So, for example, if I do electrolysis of molten lead to bromide. Now, lead to bromide means the lead will be positive and the bromide will be negative. Remember that the number of positives or negatives is the same as the valency. So lead, we're saying that it is lead 2. That means that the valency is 2. That means it will have 2 positives. The bromide is bromine ion, or the ion made from bromine, and bromine is in group 7. The valency of bromine is 1, so it will have only 1 negative. Okay, now which one goes to which electrode? We know that the negative goes to the positive electrode, the positive goes to the negative electrode. Now, the negative will go to the positive and do what? Lose electrons. Now, Br minus, when it loses electrons, it becomes bromine, and bromine is diatomic, so it has to be Br2. That means that before the arrow I have 1 bromine, after the arrow 2 bromines. I have to balance it, so I put 2 before the Br minus, and that means that now I have 2 negatives before the arrow, so I need 2 electrons after the arrow. That's how we balance this kind of reactions. Okay, then name the product at the anode. Bromine. Remember, it is now bromine, not bromide. Br2 is bromine. Br minus is bromide. When it's an ion, it is ide or whatever, but after the when it is an atom, then it is just bromine. Okay, so if we say name the product, bromine. What is observed? What is observed at the anode is reddish brown fumes, because you should realize that bromine is reddish brown. Usually it is a liquid, but remember that we are heating all of this to have molten lead bromide. You need to heat all of this, so all of this is at a very high temperature, so the bromine here is in the form of vapor or fumes. Now the lead 2+ will go to the cathode and do what? Take up electrons. When it takes up electrons, it becomes lead, and as it is, we have 2 positives, so we need 2 electrons to balance the charges. Now that means if we say name the product at the cathode, it's lead. What is observed at the cathode is gray metal or deposits. Okay, so that was molten. Molten means I just have only the ions from the compound. But if we're doing electrolysis of aqueous solutions, so an aqueous solution means that in addition to the compound we're talking about, we also have water, and water will ionize. So if I say concentrated hydrochloric acid, now the first thing we ask ourselves, what are the ions present in the electrolyte? Well, we have from the HCl, we have H+ and Cl-. But also we have water that ionizes, and when water ionizes, it forms H+ and OH-. You should remember that. Okay, so any positive goes to the negative electrode, any negative goes to the positive electrode, but only one substance can react. So if we have a choice between 2 things, only one of them can react, and there are separate rules for each of these. So let us see what is happening. Now, in this case, I have 2 types of negative ions. I have chloride ions and hydroxide ions. Both of them will be attracted to the anode. So if he says which ions are attracted to the anode, both chloride and hydroxide ions are attracted to the anode. But only one of them can react. Now, when we're choosing between chloride and hydroxide, the one present in higher amount is the one that reacts. Okay, this applies to chloride and hydroxide. Chloride and hydroxide, the one present in higher amount is the one that reacts. So if I say I have concentrated HCl, that means I have more chloride or more hydroxide. Concentrated HCl means I have a lot of HCl, only a very small amount of water. So the chloride ions are in larger amounts, so it is the chloride ions that will react, give up electrons, and change into chlorine, forming bubbles of green gas. On the other end, at the cathode, the only positive ions we have are H+, so the H+ takes up electrons and becomes hydrogen. And to balance, we need 2 positives. So this is balanced with 2 electrons. And of course, you should realize that if he says what is observed at the cathode, what I see is bubbles of colorless gas. Don't say, when he asks what is observed, don't say hydrogen gas. That's not an observation. If he says name the product at the cathode, it's hydrogen. But what is observed at the cathode, it's bubbles of colorless gas. Okay, so notice that the chloride reacts and the H+ at the anode, and the H+ reacts at the cathode. Okay, what if we're talking about concentrated sodium chloride? Again, which ions do I have? Well, I have the ions from the sodium and the chloride, so that's Na+ and Cl-, but I also have H+ and OH- from the water. Okay, choice. Now, if we're talking about sodium chloride, this is concentrated sodium chloride. We said if we're choosing between chloride and hydroxide, which one reacts? We said the one present in larger amounts. If I have concentrated sodium chloride, that means I have more chloride than hydroxide, and that means it is the chloride that reacts and forms chlorine gas at the anode. Remember that this is the method used to manufacture chlorine gas. So if he says how is chlorine gas manufactured, remember the word manufacture means made on a large scale. So when they try to make chlorine gas, they use this kind of reaction, electrolysis of concentrated sodium chloride solution. Okay, on the other end, on the cathode, I have a choice between Na plus and H plus. Now, which one is going to react? When we are choosing between Na plus and H plus, well, then it is H plus that will react, not the Na plus. So if the Na plus and H plus are present, then it is the H plus that reacts. Remember that in the other when we were doing molten sodium chloride, it was the sodium that reacted because there was no other choice. It was only sodium ions that we had, so it had to take up electrons and become sodium. But if there is something else like H plus that can take up the electrons, then it is the H plus that will react, take up electrons, become hydrogen, and give bubbles of colorless gas. And that means in the electrolyte, the chloride has reacted, the H plus has reacted, and we're left with what in solution? We're left with Na plus and OH minus. So sodium hydroxide would be left in solution, and that means if I have some sort of indicator, it will show that the solution has become basic. Okay? Okay, what if we're doing dilute sodium chloride? Again, sodium chloride solution means I have the same ions as we were talking about, Na plus with Cl minus, and the ions from the water, H plus and OH minus. Again, at the anode, which one is going to react? Remember, we said if we're choosing between chloride and OH minus, which one reacts? We said the one present in higher amounts. If we're talking about dilute sodium chloride, which one is present in higher amounts? Dilute means I have a lot of water. That means I have a lot of OH minus. So in this case, dilute solution, it is the OH minus that reacts. So when the OH minus reacts, this is what it gives. It will give oxygen gas, water, and electrons. Remember, when OH minus reacts, it gives oxygen plus water plus electron. And when you sit down and balance this equation, you will find that this is how it's balanced. So what is observed? Remember that water is not something that is unique because the whole solution is full of water. So actually what is observed is the formation of the oxygen gas, so that is bubbles of colorless gas. On the other end, we said if I have a choice between Na plus and H plus, which one reacts? Always the H plus. The Na plus does not want to take up electrons unless if it is forced to, if there is nothing else that can react. Okay, so observation at the cathode, bubbles of colorless gas. What if we're doing aqueous copper sulfate? Remember that we're still using graphite electrodes for all of this. Now, aqueous copper sulfate, what are the ions that we have? Well, we have copper, and we said the number of charges is the same as the valency. So copper, this is supposed to be copper 2. Actually, we use copper 2 in the syllabus only. So copper 2 plus and sulfate 2 minus. And then we have the ones from the water, H plus and OH minus. Okay, which one works at the anode? Now we have a choice between what and what? A choice between sulfate and hydroxide. Well, remember, sulfate will not react at all in our electrolysis examples. So it is the OH minus that reacts. And when OH minus reacts, it gives oxygen and water and electrons, and we observe bubbles of colorless gas of oxygen. Okay? Are you following the rules? There are different rules. We said, when we were choosing between chloride and hydroxide, which one reacts? We said the one present in larger amounts. When we were choosing between Na plus and H plus, we said which one reacts? The H plus will always react. Now, if we're choosing between copper 2 plus and H plus, now it is the copper 2 plus that will react. So copper is below hydrogen. Well, we'll talk about that, but it is the copper 2 plus that reacts. It takes up 2 electrons and become copper. So what is observed is red metal or reddish brown metal deposits or precipitates out. Okay, so in this case, the copper 2 plus has reacted, the OH minus has reacted, and that leaves what in solution? What am I left with in the electrolyte? If the copper 2 plus has already reacted, the hydroxide has reacted, we're left with the sulfate ions and the H plus ions. This forms sulfuric acid, and sulfuric acid is what color? Remember that all acids are colorless. Okay? All acids are colorless. So we started with copper sulfate solution. Do you remember the color of the copper sulfate solution? Copper sulfate solution is blue. At the end, we ended up with sulfuric acid. So the blue solution turned colorless. Okay? Okay, what if we're doing dilute sulfuric acid? Again, which ions do we have? We have H plus and the sulfate from the sulfuric acid, and we have H plus and OH minus from the water. Now we're comparing at the anode between sulfate and hydroxide, and we said when we compare between sulfate and hydroxide, which one reacts? The hydroxide reacts. Sulfate will never do anything in our electrolysis examples. On the other end, we have H plus ions, and that gives hydrogen gas, so we see bubbles of colorless gas. Okay, so this is a question. Okay, so the diagram shows the electrolysis of dilute sulfuric acid. Hydrogen is formed at the negative electrode and oxygen at the positive, and concentration of sulfuric acid increases. The ions present in the dilute acid are these. So he already gives me the ions present. Write an equation for the reaction at the negative electrode, the cathode. Okay, the cathode is negative, so which of these ions will go to it? The positive, so the H plus is the one that reacts, and we said when the H plus reacts, it takes up electrons and becomes hydrogen. Now he's saying complete the equation for the reaction of the positive electrode. So at the positive electrode, it is the hydroxide ion that reacts, because we said the sulfate never does anything here. So we said this will give this kind of reaction. Do you remember the balancing? If we have 4 hydrogens before the arrow, so I need to have a total of 4 hydrogens after the arrow. Now before the arrow, I have 4 negatives, so I need 4 electrons. Okay, so he's saying suggest an explanation of why the concentration of the sulfuric acid increases. Well, obviously, the H plus and the OH minus are the ones that are reacting. That means the water is being used up, because the H plus and the hydroxide ions are the ones that react at the electrode. Okay, another sample question. He's saying suggest the product formed at each electrode when molten copper 2 chloride is electrolyzed. Again, remember that molten means I have no other ions, I have no choice, I have only copper ions and chloride ions. Copper ions are positive, so they will go to the negative. Chloride ions are negative, so they are the ones that go to the positive. And remember that when the chloride goes to the positive, it forms chlorine, not chloride. So the product at the positive is chlorine. Now the copper ions will go to the negative and form copper metal. So always the metal goes to the negative, the non-metal goes to the positive. Again, molten magnesium bromide. What happens at the positive anode and what happens at the negative electrode? Magnesium ions are positive, they will go to the negative, which is the cathode. Bromide ions are the ones that will go to the anode and form bromine. The magnesium ions will go to the cathode and form magnesium. Do you get the idea? Sodium chloride is also a salt. Solid sodium chloride does not conduct electricity. So just 2 things you would do to make solid sodium chloride conduct electricity. If I have solid sodium chloride, what can I do to make it conduct electricity? Well, we said ionic compounds will conduct electricity if what? If molten or in solution. So what I should do is either dissolve it in water to form a solution or heat to melt it so that it becomes molten. Okay, choose a word from the list below which describes the positive electrode. Positive electrode is called what? Positive electrode is called anode. State the name of the product formed during electrolysis. What is he doing now? He's doing electrolysis of what? He's doing electrolysis of molten zinc chloride. Okay, molten zinc chloride. Well, which one goes to the negative? The zinc ions will go to the negatives and form zinc. The chloride ions will go to the positive electrode and form chlorine with an N, not with a D. So just the name of a nonmetal which can be used for the electrodes in this electrolysis. Remember that these are using inert electrodes, and we said which nonmetal is used. Remember that we said if he says which nonmetal, the nonmetal is carbon. If he says which substance, then you can say graphite. Okay, when molten potassium chloride is electrolyzed, two products are formed. Complete the table below to show the name of the electrodes and the product forms. If the electrode is positively charged, then it is called, if it is positively charged, it attracts the negative ions. The negative ions are called anions, so this electrode is called anode. Now the negative electrode attracts the positive ions. Positive ions are called cations, so this is called cathode. Okay, when we do molten potassium chloride, so he's doing electrolysis of molten potassium chloride, what forms at the positive? Well, the one that goes to the positive is the chloride ion, so it forms chlorine. Which one goes to the negative? The potassium ion, so it forms potassium. Okay, metals form at the cathode, non-metals form at the anode. The apparatus shown below is used to electrolyze concentrated aqueous sodium chloride. Suggest a suitable substance which could be used for the electrodes. Which substance can we use for the electrodes? In this case, I can say graphite. The other question said which non-metal, or sometimes you will say which element, then we say carbon. State the name of the gas given off at A and B. Okay, what is he doing? He's doing concentrated aqueous sodium chloride. So remember that sodium chloride means, and this is concentrated, means the chloride will go to the positive electrode and form chlorine. Now which one is going to react at the negative? We have a choice between sodium ions and H plus ions, but it is the H plus ions that will react. We said sodium ions will not react if there is another choice. Okay, state the name given to electrode A. Well, electrode A is the positive, so it is the anode. Explain why aqueous sodium chloride conducts electricity, but the solid does not. Remember that aqueous sodium chloride is an ionic compound, so when it is aqueous, then the ions are free to move, while the ions are not free to move when it is a solid, because the solid is a rigid crystal lattice. Do you understand that? So aqueous solution has free moving ions, while ions are not free to move in the rigid crystal lattice of the solids. Okay, what do you understand by the term electrolysis? We said what is meant by electrolysis: breakdown of a compound using electric current. What is the name given to the positive electrode? Again, that is the anode. State the name of the gas given off at the negative. Okay, what is he doing here? He's doing concentrated hydrochloric acid. So which one goes to the negative? What do we have in concentrated hydrochloric acid? We have H plus, Cl minus, H plus, OH minus. So it is the positive ion that goes to the negative, and the only positive ion that we have in here is hydrogen. Complete the following sentence about electrolysis using words from the list. So electrodes made of graphite or what? We said they are usually graphite or platinum are generally used in electrolysis because they are what? Because they are inert. The word inert means unreactive. Okay. A chemist electrolyzes a sample of molten copper chloride. Name the products formed at the electrode. So he has what? Molten copper chloride. So the anode is the positive, so it is the chlorine that will be formed at the anode. The cathode is the negative, so it is the copper ions that go there and will form copper metal. Remember that what is formed is the copper metal. Write an equation for the formation of the product at the negative. Which one is the negative? The negative is the cathode. So we want the formation of the copper. So we have copper ions taking up electrons and forming copper. Do you have an idea of these questions? So this is the type of questions you expect. Okay, another use, but this is one of the uses of electrolysis. We use electrolysis for purification of copper. Usually, copper can be obtained in an impure form, raw from the earth, and then we can use electrolysis to purify it. When we do that, we have a rod of impure copper, and we have a thin rod of pure copper. Now, I want the copper ions to go to the pure copper. So the pure copper has to be the cathode, it has to be the negative, while the impure copper is the anode. So impure copper is connected to the positive end of the battery, the pure copper is connected to the negative end of the battery. And what happens is, we have these ions in solution, copper ions, sulfate ions, H plus and OH minus. Now, which one is going to react at the positive? Well, at the positive, we had choices between sulfate and hydroxide ions. But in this case, neither the sulfate nor the hydroxide ions will react, because remember, notice that now we're not using inert electrodes. We're using electrodes that have copper in it. And it is the copper electrode itself which will dissolve in solution to give copper 2+ ions, and these copper 2+ ions will then go to the negative cathode and take up electrons and become copper, so they will deposit on the cathode. So what happens is the anode dissolves in solution, so as such it will become smaller and smaller, while the cathode, at the cathode, the reddish metal of copper deposits on the electrode, so the electrode becomes thicker. We have to know this. Okay, so this is a sample question on this. Copper sulfate was electrolyzed using the apparatus. A gas was formed at the anode. What do you think is the gas? If we have copper sulfate solution, so we have copper ions, H+ ions, sulfate ions, hydroxide ions, and he's asking about the anode. The anode is the positive electrode. So which one, what happens at the positive? Well, we get oxygen gas. That's what we get at the positive. Okay, electrolysis was repeated using copper electrodes in place of carbon electrodes. So he gives the half equations of the reactions at the two electrodes, and he's saying that the anode changes from copper solid to copper ions, while at the cathode the copper ions change to copper solid. So this is what happens when we do purification. The mass of the anode decreases because the copper metal dissolves in solution to form copper ions, while the cathode increases in mass because the copper ions deposit as copper metal on the electrode. So the next thing we need to talk about is electroplating with silver or with any other metal. So for example, if we have a spoon made of steel, I want to cover it with silver, then we can do electroplating. So the process of electroplating means covering a metal with another metal using electric current. Covering a metal with another metal using electric current. The first question would be, why would I want to cover a spoon with silver? Well, there are many reasons. Remember that silver is not reactive. So if the spoon is covered with silver, it will not corrode. So the electroplating with silver is done in order to protect the spoon from corrosion, or in order to give it a nicer appearance or a more expensive value, because if you cover it with silver it looks more expensive. So These are the reasons why we would do electroplating. So how do we do electroplating? The spoon is connected to the negative. So and this could be a spoon or it could be an ornament, some sort of metal that we want to cover with a specific metal like silver. So the spoon is connected to the negative and the silver rod is connected to the positive. And what happens is the silver rod dissolves in solution to give silver ions, and then the silver ions go to the other cathode, to the other electrode, the cathode, and takes up electrons and becomes silver. So it deposits on the surface of the silver. So to electroplate a spoon with silver, we connect the silver rod to the positive end of the battery, and this is of course using copper wires. Clean the surface of the spoon with sandpaper. Remember, before we do electrolysis, we need to clean the surface of the spoon. Now, if we're asked why do we need to clean the spoon, this is to allow the silver to stick to the surface, And usually we use something called sandpaper, which is rough paper that is used to smooth out or clean the surfaces of metals or other substances. Then we need to put the spoon into a solution containing silver ions. So we want something silver, something that dissolves. And remember that all nitrates dissolve. So silver nitrate would be a solution that dissolves, or a substance that dissolves in solution. And this will give silver ions. The silver ions will then deposit on the spoon when we connect it to the negative end of the battery. So what happens is the silver metal connected to the positive will dissolve to give silver ions. The spoon is connected to the negative, so the silver ion deposits on it to form a layer of silver on the spoon. Now, while we're doing electroplating, we need to have two precautions. The first one would be the one that we said, clean the surface of the spoon, and we said we clean the surface of the spoon to allow the silver to stick. But I also need to rotate the spoon during the electroplating. Why do you think we should rotate the spoon during electroplating? We say to cover it evenly, or to have an even coat of silver on it. Okay. Name the process used to coat the copper key. We said the copper key here. If he has it, this is called electroplating. So he has a copper key and he's trying to cover it with nickel using electricity. This is called electroplating. Again, why was the key rubbed with sandpaper? Remember that before we start, we should clean the surface of the key with sandpaper to clean it was rubbed to clean the surface so that the nickel can stick to it evenly. Name a possible electrolyte. What was he trying to do? He was trying to cover it with nickel, so the electrolyte has to be nickel something, and it has to be a solution, not molten. So it is aqueous nickel nitrate or nickel nitrate solution. Remember, don't say nickel sulfate or nickel something carbonate or something, because, well, you may not know whether it's soluble or not, but we're sure that if it is something nitrate, then it is soluble. Give one expected observation during the 10 minutes that the circuit was switched on. Again, when you have the circuit, it has a bulb, then while there is electricity, the bulb lights up. Describe how the key would be washed and dried. Of course, after we finish, we need to wash it and dry it. It's just washed with distilled water and dried in an oven. Remember that here, this is a key, a metal, so we dry it in an oven. We don't need to say dry between filter papers. Okay, another thing that we need to talk about are cells. And a cell is a device used to convert chemical energy into electrical energy. Remember that all what we have been talking about, the electrolysis cell, in the electrolysis, what was happening was we were using electric current to cause a chemical reaction. Here, cells, or what we call batteries, are doing the opposite. They are using a chemical reaction to cause an electric current, or to produce an electric current. So usually what we have is we have two metals that have different reactivities. For example, I have a zinc rod and a copper rod. Which one is more reactive? Well, you should know that zinc is more reactive than copper. And I put it into a solution of dilute acid, for example, so that it will have free moving positive and negative ions. And connect it to the wire. So we have a wire connecting between the zinc and the copper. Notice that there is no battery connected. So the zinc is more reactive than copper. From the electrochemical series, we have the list of reactivities. Zinc is more reactive than copper. So the zinc will lose electrons. The electrons will repel each other in the wire and they will move from the zinc to the copper. This movement of electrons in the wire is what is referred to as an electric current. Now, if we need a cell that will produce higher reactivity, then I should have two metals that have larger difference in reactivity. For example, where is zinc and where is copper in this chemical reactivity series? Okay, what if we replace the zinc with magnesium? Then instead of zinc and copper, we now have magnesium and copper, so the difference in reactivity is higher. So this will give a higher voltage or more electric current. Okay, so let's take a look at this. We have a zinc rod and a copper rod, and we connect it. This is just a bulb, so it's connected with a wire to the bulb. Now, write the ionic half equation for the reaction of the zinc. Remember that comparing zinc to copper, we said zinc is more reactive. So it is the one that will lose electrons and become zinc ions. So these electrons that are formed will then repel the electrons that are present in the metal wire until they reach the copper rod. So the ionic half equation for the reaction at the copper rod, we have what we have. The H plus ions will take up the electrons that come to the copper rod and become hydrogen gas. The copper rod was replaced by an iron rod. Now, if I replace the copper with iron, so just the change, you should realize the difference in reactivity between them, that there is a bigger difference between zinc and copper. So if I remove the copper and I put iron, then the difference in reactivity between the zinc and the iron is lower. And that means that the bulb will not light up as brightly as it did, so the intensity of the bulb decreases. This is because the difference in reactivity between zinc and iron is less than the difference between zinc and copper. Okay, this is another sample question. He says 3 cells are set up, each using 2 metals. Put the 3, okay, he has zinc with copper and zinc with nickel and copper with nickel. So he says put the 3 metals, copper, nickel and zinc, in order of reactivity. Of course, if you have a bigger difference in reactivity, then you have higher voltage. So when we put zinc and copper, it gave 1.1 volt. But between zinc and nickel, there is 0.51. So that means that the difference in reactivity between the zinc and nickel is smaller than that of copper. So that means zinc is much more reactive than nickel, and then more reactive than copper. So the arrangement would be zinc, nickel, copper. Now, complete the labeling in cell 3 by writing the polarity, whether it's positive or negative, of each electrode in the circles and calculating the reading on the voltmeter. Now, if you notice cell 1 and cell 2. Now, in cell 1, the zinc, which is more reactive, has a negative charge, because the zinc will give electrons. So this is the negative electrode. Now, while the copper is the positive, and the same with cell 2. But if we compare between copper and nickel, we said which one is more reactive? Well, obviously the nickel is more reactive. So the nickel is the one that will have the negative charge, or will be the negative electrode, and the copper will be the positive electrode. Now, calculate the reading on the voltmeter. What do you think would be the voltage here? If between zinc and copper it's 1.1. Between zinc and nickel it's 0.5. Then between nickel and copper will be what? Would be the difference between them. Okay, now this is another question, a sample question. We have a cell that has zinc and iron rods, and we have them in dilute sulfuric acid. This is a cell. I know it's a cell because the zinc and the iron are connected only with a voltmeter. There is no battery in there. Okay, so what do we do here? He's saying, how could the voltage of this cell be increased? Well, you should realize that this cell has zinc and iron, and the difference in reactivity, this chemical reactivity series, is something that we will be talking about in detail when we talk about chemical reactions of metals. But for now, just know that it is an arrangement of the reactivities. So can you see where zinc is and where is iron? Well, that is the differences, that's the difference between the reactivity of zinc and iron. So it's a very small difference, but the zinc is more reactive than the iron. And we said, if I want the voltage of this cell to be increased, I should do what? I should choose the two metals that will have higher difference in reactivity. So let us say use magnesium instead of zinc. In that case it will be magnesium and iron. Can you see that this is a bigger difference in reactivity between the two metals? So that would give a higher voltage. Okay, this is a cell that can be set up with inert electrodes, and the electrolytes are as oxidants and reductants. So he has two beakers, one containing potassium manganate and the other has potassium iodide. And you should remember that potassium manganate is an oxidizing agent and the potassium iodide is a reducing agent. So what is happening in here? The electron flow is going from the beaker that contains the potassium iodide, and he's asking, write an ionic equation for the reaction in the right hand beaker. What is happening in the right hand beaker? Then something must be giving up electrons, so it is the iodide ions that are giving up electrons and becoming iodine. Okay, the last thing that we were talking about is the hydrogen fuel cell. The hydrogen fuel cell is a cell that uses hydrogen and oxygen to form water. Basically, the name fuel cell means a cell in which the reactants are being constantly introduced. So we're constantly giving hydrogen and oxygen. This is forming water, and then give more hydrogen and oxygen, and this is forming water. And this reaction, because when the water is being formed, electrons are moving from one electrode to the other. This movement of electrons is generating an electron flow or an electric current. Okay, so basically you're not required to know exactly the setup, but you should know that, first of all, a fuel cell is a cell in which the reactants are being constantly introduced. Then an example of a fuel cell is a hydrogen fuel cell, and the hydrogen fuel cell is basically one in which we provide hydrogen and oxygen. These react to form water. The reaction transfers electrons from one electrode to the other, so that this transfer of electrons causes an electric current. Now, the advantages of using fuel cells is that there is no harmful products. The only product is water. They are also very efficient and produce more energy per gram of fuel burnt than other normal cells. The disadvantage is that it has a very high cost because the electrodes and the membrane are expensive. Manufacturing the fuel cells involves production of toxic byproducts. So when we are making the fuel cells, this involves toxic byproducts, and the hydrogen needed is manufactured from fossil fuels, which are also non-renewable. So basically, the hydrogen that we're using is made from fossil fuels. So this is, it's really not worth this trouble for so far. Okay. Okay, let's try this question. He says we have bubbles of oxygen and bubbles of hydrogen gas. A reading on the voltmeter shows that electric energy is being produced. So just an explanation for how this energy is produced. So what do you think is happening? I have at an electrode, I have bubbles of oxygen. And at the other electrode, we have bubbles of hydrogen. So basically, we have oxygen and hydrogen into this. So the hydrogen reacts with the oxygen. This is an exothermic reaction. It produces a flow of electrons and it changes chemical energy into electrical energy. And this is basically what is happening in a fuel cell. Okay, so this is the end of electrolysis. Please try the questions and then we'll meet in the next video.